Hi everyone. Today we're going to finish up talking about multiplying polynomials. We've been working on this for about 2 weeks, and in fact what I want to do is start by going through every step that we've done, partly as a review, but also because it leads up to what we're going to do today. So we started by just multiplying terms, just one single term times another single term. No parentheses, no big polynomials, anything like that. So basically what we have here, this 7x cubed y, that's one term. That dot in the middle, that's our multiplication sign. And this 4x squared y to the fifth z cubed is our other term. And what we decided, the rule for this is just go through one at a time. You do the number part first, and then you do each variable one at a time. So for my number part, I would have 7 times 4. For my x part, I would have x cubed times x squared. For my y part, I would have y times y to the fifth. And for the z part, I would just have the z cubed from the second term. The first term doesn't have a z in it, so I'll just leave that one. So we have 4 little mini problems. If you answer each question and put it all together, that's our final answer. So if you start with the number part, 7 times 4 is 28. Now for each variable, remember we learned a rule. All you have to do is add the exponents. Because what you're saying is, like if I do x cubed times x squared, I have 3 x's here, I have 2 more here. If I multiply them all together, I have 5 total, that's x to the fifth power. Now on the y's, when you have a y, when you have any variable by itself, remember that's the first power. So basically I have y to the first power, or 1y, times y to the fifth, you get 6 total, or y to the sixth power. And then our last one, if you don't have anything to combine it with, you just leave. Z cubed. So that's our final answer. 28, x to the fifth, y to the sixth, z to the third. So that's step 1 in knowing how to multiply polynomials, is just knowing how to multiply terms. Step 2 was the distributive property. So we said, okay, well, we're still going to take one single term. I'm starting with one term. That's 5ab squared. Only instead of multiplying it times another single term, I'm multiplying it by something in parentheses that has more than one term. So for the distributive property, we said we're just going to take that one out front, that 5ab squared, and one at a time we are going to multiply it by each term inside the parentheses. And the way we usually show our work is with these arrows. So I draw this little arrow, which means I'm taking the 5ab squared, and I'm multiplying it times 3a cubed b squared. So let's do that. Now remember, each one of these is exactly like we just did in the last example. It's multiplying terms. So you say, I'm going to do the number part first, 5 times 3. And then I'm going to do the a part second, a times a cubed. And then I'm going to do the b part third, b squared times b squared. And that would give me 5 times 3 is 15. A, which means, and I'll write the 1 in, means a to the first power. A times a cubed, 1 plus 3 is 4, so I'll have a to the fourth power. And b squared times b squared, 2 plus 2 is also 4. So I get 15 a to the fourth, b to the fourth. And that's basically half the problem for this one. What I would do next is this. So I'm going to do 5ab squared times negative 7b. And I'm going to do it the same way we just did. So I'll put a plus in the middle to separate them. I do the number part first. I have 5 times negative 7. And I put the negative 7 in parentheses so you know it's multiplying and not subtraction. You don't want to think it means 5 minus 7. We do the a part second. It has an a, and that's it. And then we do the b part last. We have b squared times one more b. So to finish this one out, when I do my number part, 5 times negative 7 is negative 35. So I'm going to start with a minus 35. The a we'll just leave in the question. And then for the b's, I have b squared times, remember that b is b to the first power. 2 plus 1 is 3. So I have b cubed. And that is my final answer. So what we do for distributive property is you do the multiplying term problems again. You just have to do it more than once. You have to multiply terms for however many there are inside the parentheses. So that was step 2 in the process, is learning the distributive property. Step 3 is what we just did in our most recent lesson. And that's what we called multiplying binomials. So now, instead of one single term, binomial means 2 terms. So we have one thing in parentheses with 2 parts, that's the 2x cubed minus 6x, times the same thing, another one with 2 parts, x squared plus 4x. And what we did for this one, we did distributive property, but twice. So I said, the first thing I would do for this problem is start with the very first term you see, the 2x cubed, and distribute it to the other one. So not the negative 6x, skip the negative 6x, take the 2x minus 3 and distribute it like that. So I will have 2x cubed times x squared. Now we've gotten pretty good at multiplying terms, so I'm going to skip that middle step where I kind of write it out separately, and I'm just going to do the multiplying. So I go 2 times nothing, we'll just leave the 2. X squared times x cubed, 3 plus 2 is 5, so I would get 2x to the 5th. Okay, then you do that, you multiply again. So we're going to do 2x cubed times 4x. So you say 2 times 4 is 8, that's positive, so I'll put a plus 8. And x cubed times x to the 1st, I'll put the little 1 there to remind me, 3 plus 1 is 4. So I get 8x to the 4th. Okay, we're basically halfway done with the question. We did the 2x cubed. Now what we want to do is do the same thing with this negative 6x right here. We're going to distribute that also. So I would do negative 6x times x squared. Negative 6 times nothing is negative 6, so I'll lead with a negative 6. And then we have x to the 1st times x squared, that would be x cubed, 1 plus 2. And then to finish out the question, we do negative 6x times 4x. And we go number part first. Negative 6 times 4 is negative 24. X to the 1st times x to the 1st, 1 plus 1 is 2. So you get x squared. Now, you always want to check on these to make sure that you don't have any like terms. Like if I had an x cubed here and an x cubed here, I could add those together. This one actually doesn't have any. We have x to the 5th, x to the 4th, x cubed, and x squared. So I would just box this one up and be done. This is going to be my final answer here. So that's what we've done so far. This is what we've been doing for the past about 2 weeks in class, is learning how to multiply terms, work with exponents, distributive property, and then multiplying binomials. The last step in the process is to take a look at some larger polynomials. Instead of just binomial 2 terms, what if we have 3 terms, or 4 terms, or 5 terms? What if they keep getting bigger and bigger and bigger? So I said, just like the last example we did, we're going to do it using distributive property again. But as the polynomials start getting bigger and bigger, you might need to do the distributive property more. You might end up with more terms in your answer. So if you have 3 terms that you have to distribute, you have to do distributive property 3 times. So the rule is just distribute every term of one of the polynomials to the other one. And be careful, you might end up with a lot of terms, and then at the end you combine your like terms. So let's try this out. Here's our last example for today. We are going to multiply x squared minus 4x plus 3 times 2x plus 4. So let's go ahead and start with the x squared. I'm going to start by taking this x squared and I'm going to distribute it to the other polynomial. So I'm going to jump all the way over to the 2x here, and I'm going to multiply x squared times 2x. Now when I do that, I do the number part first. I have a 2 in there. I'll just leave it. There's nothing to multiply it by. And then I have x squared times x to the 1st. 2 plus 1 is 3, so I get x cubed. Then we'll multiply by the 4. And x squared times 4 would be, basically just put it together, 4x squared. And it's positive, so I'll put plus 4x squared. Okay, then we move to our next term. That would be negative 4x right here. And I'm going to distribute that. So I'm going to do negative 4x times 2x. We do number part first. Negative 4 times 2 is negative 8. X to the first times x to the first would be x squared. So I get negative 8x squared. Then over here. Number part first. Negative 4 times positive 4 is negative 16. And we have an x there. We'll just leave it. Now see, when we're multiplying binomials on the last example, we were done here. But we still have one more number. We still have that 3. So I have one more step in this problem. This 3 here also needs to be distributed. So I'm going to do 3 times 2x. Number part, 3 times 2 is 6. It's positive, so I'll put a plus 6. And then we'll just leave the x there. And finally, 3 times 4 is 12, positive, so I'll put a plus 12. So you can see for this one, I had to do the distributive property 3 times, and I separated it by color to make it really stand out. In blue, I distributed the x squared. In purple, I distributed negative 4x. In green, I distributed the 3. But each one, I was doing the same thing. I was multiplying by the 2x first and the 4 second. Now to finish the question, what we want to do is combine our like terms. So I'll start here. I have a 2x cubed and nothing to combine it with, so we'll just leave that. And remember, kind of like when we did adding polynomials, after I use them, I like to strike them out so I don't miss any. I have a 4x squared and a negative 8x squared. Those are like terms. I can add them up. 4 and negative 8 would give me negative 4x squared. Okay? Use those. I have a negative 16x and a positive 6x. Add those together, that would be negative 10x. And then I have that positive 12. That plus 12 we'll just leave on the end. So this is going to be my final answer here. 2x cubed minus 4x squared minus 10x plus 12. Now, before we end notes today, there's one thing I want to add. If you remember from the last slide, the way I worded it, I said you have to multiply every term of one polynomial times the other. Now, usually we do the first one times the second one, but you don't have to. So I'm going to start this exact same problem again, but I'm going to kind of distribute backwards, and I want to show you that we get the same answer. So a different way to do this question would be to say, I'm going to start with the 2x here, and I'm going to distribute it backwards into the first one. I'm going to do 2x times x squared. That would be leave the 2, and then x squared times x to the first gives me x cubed. 2x times negative 4x. Number part, 2 times negative 4 is negative 8. X times x is x squared. Then 2x times 3. So I'm distributing to 3 different terms this time. Number part, 2 times 3 is 6, positive, with an x on it. Then for step 2, I'm going to distribute the 4. So we do 4 times x squared. That would be 4x squared. 4 times negative 4x. We do 4 times negative 4 is negative 16. Leave that x on there. And then 4 times 3 would be positive 12. So I'll end with a plus 12. Now you end up with the exact same 6 terms. They're just in a different order. But when you're combining like terms anyways, you go, okay, well, here's my 2x cubed. That was the same as my last answer. Here's my negative 8x squared and positive 4x squared. That's negative 4x squared, same as our last one. Here's my positive 6x and my negative 16x. That's negative 10x, same as last one. And it ends with the plus 12. So we got the exact same answer twice in a row. And I just wanted to show you, it doesn't matter which one you do. You can take the first polynomial and distribute it to the second one. Or you can take the second polynomial and distribute it to the first one. You still get the right answer, either way.